important unit. Why? Because of here. In so many cases, and that means if you observe the previous question papers, you may have so many times these questions have been the examiner given. So that's why I use it to say always that this chapter or else this unit is very, very important. By means that here by combination of two questions may be asked as a essay question. Okay. So many times. That means whether it is a current follower or voltage follower combination, and op amp differentiator short question or op amp integrator is a short question. Okay, now. So inverting or non-inverting amplifiers. Okay. So let us discuss about the what are the objectives we are going to discuss and what is the introduction portion about this here. So under the ideal condition for the voltage effect inverting as well as the non-inverting terminals of an op amp which are equal, then it is called as a principle of virtual equality. So the principle which is going to be enables us to analyze the different types of op amp configurations in a simplest way. So this principle which can leads us to the concept of virtual ground and the gain of the op amp. Gain means output voltage by input voltage. With the feedback network is called the closed loop gain. So let us discuss for the simple model for the ideal op amp. So what is the output voltage of an ideal op amp is V naught equals to A naught into V plus minus V minus. Okay. So where V plus and V minus are the voltages applied at the non-inverting and inverting input terminals. So if with the finite values for the V naught and the very large values for A naught. Okay. So how it comes means here you can derive the questions that is V naught equals to A into V plus minus V minus. So based on this V naught by A is nothing but a V plus minus V minus. Okay. So if you say that if it is approximately 0, if it is approximately 0 means V plus minus V minus equals to 0 or V plus equals to minus V minus. V plus equals to V minus. Okay, here there is a print mistake. There is a print mistake. Okay. So you can go for that. And most of the conditions you may observe so many print mistakes are there. You can go for that. Here the non-inverting terminal. Non-inverting is positive, which is grounded. Inverting is this one, minus. There is a signal is to be applied, voltage is to be applied. Okay. So by this inverting amplifier, here S is a virtual ground here. So which is called S called the point S is a virtual ground. So here when two resistors which are connected in together at this common virtual ground, this one, they will not cause any significant voltage coupling between the input and signal sources. This is essential that no voltage present at this common point. Where? At a point S. So the virtual ground isolates the input signal source from each other. So here V plus is grounded here, that is inverting amplifier. Okay. This is the non-inverting terminal. You are sending the voltage. This is the input resistance here, which may have the II current, and the feedback resistance is RF, which is connected to the input at point S. S is a virtual ground. Okay. And there the resistance value is RF. There only the current is IF. So that we are taking the output voltage. But you are sending the for an inverting amplifier, if you send a positive half cycle and negative half cycle, that means a signal is to be sent, sine wave, AC signal. Whereas you may get here inverted. Okay. Strength is enhanced. The thing is that here which is inverted. Getting my point? That is the case. Next, how the scale is changing in inverting amplifier. So the basic op amp, why? Because of here V plus is 0 and V minus is also 0 condition. So the current through the input resistance is II, that is nothing but a RI. Neat. So spoon. So here I equals to not 1 and that is I equals to V by R. Why? Because of here Ohm's law, V equals to IR or I equals to V by R. Not is a 1. So many print mistakes are there. You can go through that. Okay. So we assume that infinite input impedance, no current flows into the op amp. Then the current I flows through the RI and RF at the output voltage I equals to VI by RI. If V naught equals to minus I into RF, or else VI equals to RF by RF. Okay. Once you check it once, how the equation can give you here. Whether it is correct or not, you can check it once. The ideal closed loop gain, output voltage by input voltage, V naught by VA. That equals to RF by RI. Okay. Let us, there is a phase inversion between the input and output signals. Therefore, op amp closed loop gain is dependent only on the ratio of the feedback and input resistance. Hence, it is used for multiplication. Therefore, if RF by RA is 10 ohms, that means the input voltage which is multiplied by 10 factor. On the other hand, RF by RA is 1 by 10 and which is divided by a factor is 10. So which can be used as a both amplifier, multiplier and as well as the divider. So in general, this is called as a scale changing amp. So here there is an example. You can have output voltage, how the minus 10 volts comes out here. What is the 1 milliampere means RI? Okay. See here. RI is 10K. And input voltage is 10 volts. V equals to IR. I equals to V by R. 10 by 10K. So 10 by 10K means 10. K means 1000 kilo. Okay. That means here you may get 1 by 1000. 1 by 1000. That means 1 into 10 power minus 3. That is nothing but 1 milliamp. Okay. Here in this portion, how the current is 1 milliamp. So similarly here also, getting it? Current is there 1 milliamp and RF is 10K. You can simply calculate. Okay. Current is there, R is there. 1 into 10 cube into what is that? Here, this equation. I is 1 into 10 power minus 3 ampere into R is 10K in 10 into 1000. So what you will get? That is a 10 power 1 into 10 into 10 power minus 3 into 10 cube. This may be written as 10 cube. So we both get cancelled. What is the answer? Where? This. But the thing is here, which is a non-inverting. That means minus 10 volts. You can simply put minus. So summing amplified. So here, the sign summing amplifier, there are 3 input sources. VA, VB and VC. Here resistors are RA, RB, RC. Therefore, across the resistance, what is the current? IA, RA, RB is IB, RC is IC. So the working of this summing amplifier can be understood using the concept of virtual equality. Virtual equality means V plus equals to V minus equals to 0. Therefore, here the non-inverting terminal which is earthed. Here, non-inverting terminal is earthed here. That is V plus. This one. So we are sending the inverting. This is inverting amp. So what is the total current here? At point S, IA plus IB plus IC. Due to these different voltages, which are applying and where the current which is moving toward the different 3 resistors, RA, RB and RC, there you may get IA, IB, IC. But whenever these are to be reaching a point, yes, there only the sum of these two, these three, that is IA plus IB plus IC, which is fed through the RF. So what is the output voltage? Okay. So summing amplifier, you can go for this equations. Output voltage equals V equals to IR, same thing. Minus RF into IA plus IB plus IC. So minus IF into IS signal, we are saying. Minus IF into here IS means IF plus IQ. That maybe gives as a minus RF into IF. If all are same, then V naught equals to VA plus VB plus VC. So that here the output voltage which is equals to the sum of the three input voltages. That is RA plus RB plus RC. That is RA equals RB equals RC is 3 RF. Substitute that is in above equation RF value V naught equals to minus 1 by 3 VA plus VB plus VC. So which is act as an inverting averaging circuit. So weighted the average of three inputs. RC equals to RF equals to minus 1 by 3 RA and RB is 1 by 2 RA. By substituting, you may have V naught equals to minus 1 by 3 VA plus in place of VB 2 VB plus 3 Vs. So in computing the average, we may have the output voltage V naught is twice much as the weight as VA and VC is thrice much as the weight of V. So the output voltage is weighted average of 3 volt. Next is the non-inverting amp. Okay. So this is the inverting terminal, this is non-inverting terminal. If it is grounded here, this is Ri and where Ii and this is the actual point. Yes, this is RF. Y is passing through this voltage V0 and VA is there signal. So in op-amp non-inverting configuration, according to the principle of the virtual equality, see here V plus equals to VA equals to V minus, then I equals to VI by R. So the current which may flows through the feedback resistance RF equals to V naught equals to VI plus VF. What is VF here? I into RF. VI plus VF is VF plus RF. So VI is there and this is the VF and not VA and VF, which may be equals to RF by RA. So if you commoning this 1 plus, there is no equal commoning. Okay. So RF by RA 1 plus. There's so many print mistakes are there. You can please carefully observe the mistakes while you are go through the textbook. So this is the case. That means if no signal, that is no sign change, it may be noted that the configuration, no current which is drawn from the source Vi, that is inverting amplifier, plus is the inverting amplifier. You can go through this. This is inverting, this is non-inverting. So hence the impedance, input impedance is high. What is current follower? So here this is inverting and this is non-inverting. So the output voltage which is proportional to the input current. Okay. Then it is going to act like a current to voltage converter. So what is the output voltage V naught here? Minus I into RF. Let us consider that gain is 10 power 5 and the value of 100 kilo ohms per RF leads to 1 ohm input resistance. Then the configuration is an ideal current measuring device, which is useful for measuring very small currents of the order nano amperes and less. So this is the current form. Next is the voltage follower. So which can be used to match the source of very high impedance to a load of low impedance. So this is inverting and non-inverting, which is fed to the input output voltage. Okay. So that V naught is approximately equals to Vi, which is matching the source of very high input. So the entire output signal fed back into the inverting input. The input signal which is connected to the non-inverting input. This one. According to the principle of the virtual equality, V minus equals to V plus equals to Vi equals. So this is called the voltage follower because the output voltage always almost equal to the input. Vi equals to V naught, which is similar to an emitter follower in BJT, bipolar junction transistor, or a source follower in FET amplifier, field effective transistor amplifier. So this is due to the fact that a large gain does not allow a large differential voltage. What is an op-amp integrator? The circuit diagram of an op-amp, which is showing here, this one. Op-amp integrator. So the non-inverting terminal is also active. The inverting input is at the ground potential. And the current I through the resistor R is given by, according to the Ohm's law, I equals to V by R. So Vi by R. And the voltage across the capacitor, which is equals to the output voltage. So you know pretty well C equals to Q by V, or Q equals to CV, and V equals to Q by C. Capacitance formula. Okay. Sir, how do you written this equation means? I will tell you. I equals to Q by T, current formula. R Q equals to IT, R integral I into T. Okay. C equals to Q by V, or Q equals to CV. Okay. Here you can substitute. So by substituting CV equals to integral IDT and V equals to 1 by C integral IDT. Getting my point? Where I equals to V by R. Again, here. I equals to V by R. Substitute what you will get from this equation. 1 by C integral V by R dt. Okay. That may be written as V equals to 1 by CR integral V dt. So this is the equation. In place of V, we are writing V naught. Got it? So op amp integrate. This is the op amp integrate. So here which is grounded and non-inverting, we are sending the signal like this. In place of resistor, we are using capacitor. Okay, integrator. In differentiator, we may use resistor, interchange. Here resistor, capacitor. In differentiator, here capacitor and resistor. You can go through this. This is the differentiator. Did you see in this diagram? You can observe. This is one. So what is CR? CR is nothing but a time constant. Tau. So the characteristic time of the integrator. 1 by tau, which may gives the gain of the integrator. And if the time constant tau of the integrator RC, which is equals to the 1 second, by substituting all these, then the expression which may reduces to V naught equal minus V naught equals to VA into d tau, and the input voltage VA equals to VI by integral dt is T, integral dt is T, T is 1 by T equals to RC, 1 by RC. That is the case. So that for this condition, the output voltage varies linearly with respect to time, and it is produces a ramp voltage. If you send a square wave to it, then you may get a triangular wave for this integrate. Next is the differentiate. Op amp differentiate. Here, this differentiator is op amp active. Here, non-inverting terminal is grounded in this. Where S is the virtual ground, the current through the capacitor. Here, interchanging integrator. In integrator, here capacitor and here resistor. In differentiator, here resistor and here capacitor. So dq by dt equals to I. I equals to dq by dt. That is equals to current value formula. That is equals to C into dv by dt. How sir? ఎట్లా రాసినారు సార్ అంటే ఇదిగోండి బేసిక్ ఫార్ములా I equals to q by t అండి, లేదా I equals to dq by dt. but Q equals to CVN. Why C equals to QV? What is C? Capacitance. Okay, substitute here. That is C into dV by dt. Here we haven't substituted. Getting my point? Therefore, feedback current IF equals to minus V naught, not into V into D. This is V naught. So V naught equals to minus IR into VF. Output voltage. Okay, this is the differential op amp. If IF equals to II, so simply you can substitute in place of minus R into IF, RI. Subtracting for IF from the equation, you may get V naught equals to minus RC into dV by dt. So here the output voltage is proportional to the difference of the input. So what is the summary of this chapter is the principle of virtual equality leads us to the concept of virtual ground. Whereas op amp can be used as a scale changer, that is a multiplier or divider or summing device or integrator or differentiator and etc. Current follower configuration ideal current measuring device. So which is useful for measuring the small currents of the order of nanoampere. Okay. So 10 power minus 9. Okay. So model questions. So in this, you may have this one most important. How an op amp can be used as a 3 voltages with necessary diagram. This question is repeatedly asking. Explain the working of voltage and current follower. Or else active integrator and differentiator. Next is the block 2, measuring instruments. So analog measuring units, instruments. In analog measuring instruments, D-Arsenal type measuring instruments and conversion of D-Arsenal PMMC type micrometer and Athlon shunt and multi-range ammeter and conversion of D-Arsenal PMMC type so micrometer into voltmeter, multi-range voltmeter, series type ohm meter. Okay. And also PET input type electrode. Let me give the introduction of this. The constructional details of a PMMC type of my OC micrometer meters. It's basic for the almost of all the passive measuring instruments like voltmeter, ammeter, ohm meter, which may improve in the accuracy measurements and which can be achieved by the use of PET input type measuring instruments. The basic movement of DC ammeter is a PMMC type galvanometer. So the coil can carry only very small currents in a few tens of microamperes. Micro means 10 power minus 6, which is always connected in series. Ammeter always connected in series. Voltmeter, which is always connected in parallel. Okay, please remember. So a DC voltmeter measures the potential difference between 2 points in a DC current. And what about the multiplier resistors, which are usually mounted inside the case of volt? And rectifier. PN junction diode is a rectifier. Okay. That means rectifier means which may convert the pulsating AC into DC. That is a rectifier. If DC is converting into AC, that is a oscillator. A beta equals to 1. Barkhasan criteria. So rectifier type instrument generally use a PMMC movement in combination with a rectifier. Let us discuss D-Arsenal type measuring instrument. Here the details of a D-Arsenal type suspension galvanometer, which is designed on the principle of a permanent magnetic moment coil. PMMC means permanent magnetic moment moving coil, which is a type of suspension galvanometer and which is suspended in a magnetic field of horseshoe type of permanent magnets, so that it can easily rotate freely in the magnetic field. Whenever a current flows in the coil, the magnetic field which is developed in the coil and which may interact with the permanent magnetic field and which may develop the electromagnetic torque and which causes the coil to rotate. So that electromagnetic torque, which is counterbalanced by the mechanical torque of control spring attached to the movable coil. So the balancing torque and therefore angular position of the movable coil, which may indicate by a pointer against a fixed reference, and the torque developed derived from the basic electromagnet. Tau equals to BAIN. Okay, then this is not 1, this is I. BAIN. And mechanical torque due to the suspension of the spring, which is tau equals to C theta. And tau is the torque, B the flux density in air, A is the effective coil area, I the current in the mobile coil, N turns of wire on the coil, C is the restoring couple for unit rotation accepted by the mechanical suspension. Theta is the angular deflection. So here I is proportional to theta. If more current, more deflection is to be observed. Okay. If less current, less deflection. Next is the conversion of D-Arsenal PMMC. Permanent magnetic moment coil, moving coil. type of microammeter into an ampere meter of higher ranges. The basic movement of DC ammeter is PMMC. So this can carry only few small currents of few tens of microamp. So when large currents are to be measured, which is not usable. Why? Because of a galvanometer which is going to be measuring very sensitive currents. Okay, up to 10 power minus 6. And below that, it is not possible. So in general, ammeter. So here, galvanometer is a very sensitive current which is going to be measuring. So the resistance of the shunt can be calculated by applying conventional circuit analysis. There you may get here Rm is the internal resistance of the movement, Rs is the resistance of shunt, Im is the full scale deflection current of the movement, Is is the shunt current, I is the total input current to be measured in the ammeter. So here the thing is that the shunt resistance is parallel with the meter movement. The voltage drop across the shunt movement is the same as the hence we can write V shunt equals to V moment. So by substituting all these, you will get R suffix S, not R into S. That is Im Rm by here what you will get I minus Im. Is means I minus Im. You have to substitute I minus Im. So many print mistakes are there. This is the basic DC ammeter circuit. Next is the multi-range ammeter, Ayrton shunt. So the current range of DC ammeter, which may be further extended by providing a large number of such selected ranges. In figure A, schematic diagram of simple multi-stage ammeter, and B is the universal or Ayrton shunt. So here four resistors, four shunts, RA, RB, RC, and RD, which can be replaced by in a parallel with the movement of to give four different current ranges, where switch S is a multi-position, which make or break type switch. Here, the DC meter is not protected while different current range reselect. This is the modification set. So this universal or Ayrton shunt, this one, which can be eliminate the possibility of having the disadvantage of is gained at the price of slightly higher overall the meter resistance. As it may achieve the position of the switch at any one of the shunt resistance. So by doing the calculation part, we can have what are the observations from this, which is always connected an ammeter in series with load. but never connected an emitter across a source of EMF, electromotive force. Because of low resistance, it will be driven damagingly high currents and destroy the delicate. Observe the correct polarity while connecting the meter. Reserve polarity causes the meter to deflect against the mechanical stop, and this may be damage the pointer. While you are using the multi-stage meter, first we use the highest current range and then decrease the current range until sustained deflection. Next, third one is the conversion of ADSL PMMC type micrometer into a voltmeter. In addition to a series resistor or a multiplier, convert the basic directional movement into DC voltmeter, and which is going to be limit the current through the movement so as not to exceed the value of the full scale deflection. So DC voltmeter which measures the potential difference between the 2 points. As a DC circuit is therefore is connected across a source and is of a EMF for a circuit component. So the meter terminal which are marked as plus and minus. So here the value of multiplier which is in series resistance which are required for a micrometer into a voltmeter. So by substituting V equals to Im into Rf plus Ri, that is Rs plus Rm. So V value is Im into Rf plus Rs. And Rs value is V by Im minus Rf. So this is the multiplier Rs. This is Rm value, input voltage. This is the basic DC voltage accruiter, circuit record. So what is Im here? Deflection current at the moment. Rm is the internal resistance of the movement. Rs is the multiplier resistor. V the full range voltage of the instrument. Next, conversion of a micrometer into a multi-range voltmeter. In addition, of a large number of multiplier resistor together with a range switch, which may provides the instrument with a workable number of voltage ranges. Here four position switches and 4 multipliers. R1, R2, R3, and R4 for a voltage range V1, V2, V3. So this is a multi-range voltmeter. And more practical range of amplifier and in the multi-range voltmeter. The variation of the circuit, figure A and figure B, which are showing here. And whereas the multiplier which are connected in series to the string of the range electric switches. The appropriate amount of resistance in series with the moment. So here, this is the case, but the low range multiplier R4 is only a special resistor which must be in play. Conversion of microammeter into a series type of ohm meter. Series type ohm meter. How to convert it? What are the conditions it is to be fulfilled? How are you going to derive the equation portion? Wherever, whatever the circuit is to be considered, which is every circuit which is consist of a directional moment. Okay. So in this, it is connected in a series with a resistance and a battery pair of terminals. And also using the unknown resistor. Here the current through the movement then which depends on the magnitude of the unknown resistor and which is proportional to the value of the unknown resistor. Okay. So here the conditions you need to fulfill here. What is R1, R2, ERM, RX, unknown resistance. Here E is the internal bat. So by doing the calculation by applying such a limitations to this, you may get R1 is RH into RH minus ISFD RM RH. So this is the case. By coming class, we will discuss again. The rectifier. Okay. Here you may have a bridge rectifier. 4 diodes are using. You are getting a full wave. What is the IRMS current value? IM by 2. Okay. So what is the IDC value? 2 IM by pi. Rectifier, how it is going to be converting a pulsating AC into a DC by directional move. Okay. So we will discuss about the FET, input type electronic volt, by tomorrow's class. Tomorrow we will discuss that. Right. Thank you. Thank you, one and all.